Hey, what's up everyone? It's Josh from Leet, where we explain coding question as simple and concise as we can. Today, we'll be talking about the letter combination of a phone number, where we'll use recursive backtracking to solve the problem. According to LeetCode, in the past 6 months, this question has been quite frequently asked by Amazon and Microsoft. So it's a good question to know, and as always, it's always good to know how to do recursive backtracking. Given a string containing digits from 2 to 9 inclusive, we want to return all possible letter combinations that could represent a number. And the answer can be in any order we want. So the mapping for this problem is just like as you would see on a phone number. 1 doesn't have any letters associated, 2 is associated with A, B, and C, 3 is with D and F, 4 with G, H, I, and so on and so forth. So if we look at example 1, we're given the digit 23. So 2 maps to A, B, and C. We want to form every combination of A, B, and C with every combination possible with D, E, and F. So that could be A with D, A with E, A and F, and same thing with B and C. In example 2, if given an empty string, we just return an empty list. And then in example 3, when given 2, we can only return A, B, or C as our total number of combinations. Whenever a problem asks you to generate every possible combination, it usually means that you need to use a recursive backtracking solution. What's nice about a recursive backtracking solution is that you start with a simple case, for example, let's say empty string, and then we just pick one combination. For example, 2 is associated with A, B, and C, so we just pick A. And then we try the next index over, which is 3. What's 3 associated with? D, E, and F. So we just say D. And then we try and see what 4 is associated with, and we pick G. And then we have our answer. And then once we have our answer, we just go back 1, remove the G, and then try another letter that's associated with the number 4, which can be H. And we keep doing this with all of our numbers until we generate every single possibility. To get an intuition of this recursive backtracking solution, we'll go through a quick high-level diagram. We always start with our base case, which is an empty string. And we start at index 0 of our string, which is 2. So we find so we want to try all the letters that are associated to, starting with A. Now in our recursion, we would add and build our letter A to our empty string, and then we would increment our index by 1 to get us to a digit 3. With our current string A, we just need to match A with all the letters associated with the number 3. We'll start off with choosing the letter D. So we build a combination A and D, and then we move our index over to 4. So what we want to do at this point is we want to match AD with one of the letters that's mapped with 4, which let's just say G. This will give us A, D, G, which is one of our solution. Then we would recursively go back to AD, and then instead of picking G, we would pick another letter, let's say H, and we get another answer. And then we go back and then try another letter, which is I, and we get another answer, ADI. And this pattern just repeats. We keep going back, and just one more quick example. We've picked D for the number 3 associated with to add to our A earlier, but instead of D, we can add E, and we can build A and E. And then this pattern just continues until we eventually build every single letter combination to answer this question. Building up from the high-level algorithm that we just went through, for every recursion problem, we need to define the state that we want to change for every recursive call that we take. We need to define a base case, which is when we know when we've reached the end of our recursion, and we need to define a recursive case, which is how we would handle traversing through our recursion when we haven't reached the end yet. So for our state, we are building up all possible letters that we want to generate. For example, ADG, which then we would save in our base case. We also pass in an integer index, which tells us what digit we are currently at to try and build up our string. And then for our base case, we know that if our index is greater than, so 2, 3, 4 would have a length of 3. So if we reach index 4, that means we have made one possible combination of trying every letters from 2, 3, and 4, and then we would save it. And then in our recursive case, we're going to build up our string from every single letter that's associated with the number. We went through this earlier, but let's say our number is 2, 3, 4. For 2, we picked A already. And so for our recursive case, we want to try concatenating A with all the letters that's associated with 3. So we would have A, D, A, E, and A, F. Before we jump to the code, I want to talk about the high-level step-by-step instructions of being able to solve this problem. So the first thing we need to do is we need to create a mapping from our numbers to our letters. So for example, we have 2, which is mapped to A, B, and C. 3 is mapped to D, E, and F, and so on and so forth. Now, assuming we have the digit 23, we start our recursive function. We start by exploring the first index of our digit, which is 2. We most likely will not immediately hit our base case, so we'll enter a recursive case. In a recursive case, we'll pick a string from our current index and add it to the substring that we're building, and we recurse to our next index. So, for example, 2 is mapped to A, B, and C, so we just pick 1 and we say A. And then we add that to our substring, which currently is an empty, and then we pass it on along with our next index. And then we keep going until we hit our base case, which we hit 3, which is another recursive case. We add D, for example, and then we increment our index to be 3, and then we hit our base case. And then once we hit our base case, we add this combination as one of our answers. And then finally, we return back to our recursive case and then try another letter. Let's say E. This algorithm will give us a O of 3 to the power of n times 4 to the power of m runtime. The reason for that is because we have to try every letter associated with a number, and we have numbers like 2 and 3, which is mapped to 3 letters. So each digit we have to try 3 combination times another 3 combination. However, there are some digits like 7 and 9, which is associated with 4 letters. So if we included 9, we have to match all 3 letters from 2 with all 3 letters of 3 with all 4 letters of 9, which is why it is 4 to the power of m. Our space complexity would also be 3 to the power of n times 4 to the power of m, because we have that many combination of letters that we need to build. In our detailed walkthrough, the first thing we need to do is we need to create our answer list and our mapping from digits to letters. One edge case we need to consider is if our digit has a length of 0. If that's the case, that means we need to return an empty list. Otherwise, we want to call our recursive function to build up all possible letter combinations. Like we mentioned earlier, in our recursive backtracking problem, there are 2 states that we are keep track of. The string that we are building up. Oops, let me make this bigger. The string that we're building up and the index that we are currently at. The 3 other variables that we're passing in is our answer list, our mapping of letters to numbers, which is represented by this, and then the digit itself that we are parsing. Now that we have this defined, let's create our helper function. Now on the whiteboard, we are currently at index 0. So right here, index 0, and we have an empty string. Now back to the code. the first thing I like to do in a recursive function is to define the base case. We know that we reach the end of the digits when our index that we're at is equal to the length of the digits. In our recursive case, we want to find the number that's associated with digits that we're currently at and find all the letters that's associated with it. I made a big mistake. This map is not a map of string to string. I'm going to quickly address this. Alright, I've adjusted everything. Notice that instead of mapping a string to a string, it's a character to a string. And notice that I added the char of the numbers that we're looking for instead of a string. Now, back to a recursive case, we now have all the letters that are associated with our given character. And now what we need to do is iterate through all of them, pick one, iterate through all of them, and then build up our answer from using each of those letters. So what we did here is we called a recursive function, we passed in our existing string, and then we added the new letter that we've picked. And let's not forget, we also incremented our index by 1 so we can check the next. And that's it for this algorithm. So to quickly walk through this with our digit 2, 3, we started off at index 0, and we see that 2 is associated with the letters A, B, and C. So the first thing we try is A. So we append empty string with A, and so we get A, and then we go into, and we increment our index by 1, so we have 1 and A. Because 1 is not the length of our index, we don't enter our base case yet, and we enter a recursive case, and we're currently right here at index 1. We map 3 with all of its letters, D, E, and F. So we pick the first letter, D, and we increment our index, and we get 2, A, D. And because index 2 is the length of our digit, we hit our base case, and so we add AD to be one of our answers. And then we recurse back from our base case, and we go back to index 1 where we picked A, and then we continue our for loop, and we pick the next letter, which is E. So go back to index 2 with AE, add that as our answer, and we just kind of repeat. We go back to index 1 with A, we chose the final letter, which is F, and so back in index 2 we have the answer AF. Now I think at this point you get the rough idea of how this will play out, so I'll just speedily go through this. And at this point I'm out of space, but it's pretty obvious to see that we will generate the answer C, D, C, E, and C, F into our list. And once we do that, we exit our recursive function and we just return our answer. Now let's quickly submit our answer. Oh yeah, I made a mistake here. I shouldn't increment I should be incrementing index. Right, let's try again. And there we go. This is how we would solve the letter combination of a phone number problem by using recursive backtracking. If you have any questions, please leave them in the comments below. If you found this video helpful, consider liking it and possibly even subscribing to get daily updates. Otherwise, I'll see all of you in the next video and have a great day.